Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we get our last section 1.6 for Chapter 1. We're going to continue our discussion about absolute values and look at also how they're connected to inequalities. So a previous lesson we talked about absolute values, a previous lesson we talked about inequalities. This lesson puts them together and we're going to talk about how to solve the two. So first of all, you need to understand the definition of the absolute value. It looks a little confusing. Sometimes the absolute value of x is x, and sometimes it's actually negative x, or I'm going to pronounce this the opposite of x, which is confusing to students because they know that the absolute value of 5 is 5, and they also know that the absolute value of negative 5 is also positive 5. So the definition looks a little deceiving because this looks like a negative, and they know that the absolute value can never be a negative number. However, the absolute value of x is a negative number for any values of x that are less than 0, in other words, negative. This definition only works for those values of x that are greater than or equal to 0. So for example, if you let x be 5, if you put an x in here, you bet you get 5 out, and that's the top scenario. But if you let x be negative 5, then this is the opposite of negative 5, which, yes, gives you the answer that you and I wanted, positive 5. So that definition is going to become helpful when we start solving these things. So here's a couple properties. The absolute value of AB is the absolute value of A times of B. You could do the same thing with the division. And as you know, the absolute value of negative A is still just A. So for example, if I do the absolute value of absolute value of 7 and the absolute value of x, we know the absolute value of 7 is just 7. Now the absolute value of x, I'm going to leave this the absolute value of x because, again, that could be a positive x or a negative x. So likewise over here, the absolute value of negative 8 and a y is the absolute value of negative 8 is 8, and I'm going to leave the absolute value around the y. This is the absolute value of 6 and the absolute value of x squared. Well, 6 just goes to 6, but x squared can never be negative. So I'm just going to say that's the same thing as x squared. I can drop the absolute value sign, unlike over here where I could end up with a positive or negative. And the reason why is because every time you square it, whether a positive or a negative, you get a positive answer. So over here I could reduce this first. This becomes 2, because 8 divided by 4 is 2, and a negative x, because when I cancel 1x up top and 1x down bottom, I'm left with 1x down bottom. So the absolute value of 2 certainly is 2. The absolute value of negative x, we've discussed before, is just the absolute value of x. So I'll leave this. There's a couple other ways you could have worked through this. This negative sign certainly could have gone to the numerator, and you could have said negative 2 divided by x. This gives you the same answer because the absolute value of negative 2 divided by the absolute value of x still gives me the same answer, 2 over the absolute value of x. Again, it's not being squared, so I'll leave the absolute value sign. So there's the author's answers as well. Continuing, looking at the absolute value is actually the distance from 0. So if I were to say I need all the values of x minus 3 that is equal to 5, this is really said I need all the values of x that are 5 units away from positive 3. Let me show you what I mean. Here's a positive 3, and if I go 5 units away, 1, 2, 3, 4, 5, that'll put me up at 8. And 1, 2, 3, 4, 5 units, that'll put me at a negative 2. So I need the distance of the absolute value of all the values of x that are 5 away from negative 3, positive 3, would be, this is 5 units away, and this distance is also 5 units away. So I would say 8 is a solution. X could be 8. X could be negative 2 because they're both 5 units away from positive 3. And I know you're looking at this as a minus sign, but it's called a root. So when does x minus 3 equal 0? When x is actually equal to 3. So it's 5 units away from, and then you have to change that sign. So to find the distance between negative 12 and negative 56, I could take the absolute value, and the distance between means to subtract negative 56 and take the absolute value of it. So the absolute value of 44 is still just 44. It does not matter if you do that in the reverse order. You could start with the negative 56 and subtract off the negative 12, which is the same thing as the absolute value of negative 56 plus 12. The absolute value of negative 44 is still just 44. The definition of absolute value, again, says x could be 6 or it could be negative 6, and oftentimes we just write that as plus or minus 6, because you could take the absolute value of 6 and get 6, but you could also take the absolute value of negative 6 and also get 6. So the solution is plus or minus. There is no plus or minus for 0, so we'll just say x is 0. For this last one, that's impossible. There's no value that you can put in here that would ever give you a negative number, because you and I remember the absolute value of x is always a positive answer. Even if x is negative, it's the opposite of the negative answer. So again, solution set plus or minus 6, zeroed, has no plus or minus, and the empty set. So those are the three scenarios that could happen. There could be two solutions, a positive answer and a negative answer. There could just be one solution, or there could be no solutions. So again, the absolute value says I'm going to take 2x plus 1 and set it equal to 5, or I could have 2x plus 1 and set it equal to negative 5, because of the same definition that I had before. If I see the absolute value of x is equal to 5, I would say x is 5, or it could be x is negative 5. So that's what I've done. All this is x is 5, or x is negative 5. And then I solve two problems separately. Subtracting 1 from both sides and then dividing by 2. Same thing over here. Subtract 1 from both sides and divide by 2 gives me two solutions, 2 and negative 3. Over here, I see that the absolute value is equal to a negative. That cannot happen. You could try this and say, well, 3 minus 4x is equal to negative 10, or 3 minus 4x equals 10, and you could kind of work through there. But again, if you were to go back and check those solutions, it won't work, because when you take the absolute value, you should end up with a positive, and you'll never end up with a negative. So I wouldn't even go through the bother of doing the work. I would simply say no solution. So again, the first solution set, negative 3 and 2, and I would say empty set, or there is no solution for the second one. Sometimes absolute values are set equal to other absolute values, so we'll have absolute values on both sides. If that's the case, we'll set this absolute value equal to the positive of this, and set the absolute value equal to the opposite of this. So 3x minus 5 is the positive, 3x minus 5 is the opposite of that. Again, same way that absolute value works. We'll distribute the negative, get all the variables on the same side, and x could be negative 13, or x could be negative 3/7. Let's talk about inequalities now. A little bit different for inequalities than equations. I would say for this one, x is, now on a previous video, I started pronouncing these a little bit differently. Instead of less than, we pronounce this less and that's a huge hint, because and statements, majority of the time, are between statements. They come together. Another scenario would be this symbol, which is greater, but we're going to pronounce it great or. And 90% of the time, or 95, 99% of the time, or statements look like this. There are exceptions, but usually and comes together. It's a between statement, and or goes to the left or to the right. So this statement just says I need all the values of x that are less than 3, and since this is a less than, I'm going to use the word and in here. And I know x could also be the negative 3, because that's what I do for absolute value. I say it could be 3, or it could be negative 3. But when I talk about inequalities and oppositeness, if I have 5 is less than 6 and multiply both sides by negative 1, I get negative 5 and a negative 6, and I have to flip that inequality sign because of the oppositeness property. So instead of less than, it becomes greater than. This is a true statement. This is a true statement. So I'm going to flip this inequality sign from less to greater than, because I took the opposite of 3 to get a negative 3. So here is created my and statement. It's really a between statement. I could rewrite this by putting the lower number on the left and use less than signs, or I could write it as interval notation, -3 to 3, and then don't include it. So it's a between statement. I can accept all those values between 3 and -3. And this is what the solution would look like, and this is what the graph would look like. Here's a scenario. X is greater than or equal to 3. I would just rewrite the problem and drop the inequality. This is a great OR, so I'm going to write the word OR, because that's a great OR symbol. X, I'm going to flip the inequality sign, because I'm going to take the opposite of 3 and make it a -3. So same scenario. I want X is greater than 3, so that would be everything over here this time though. And I would include, so I'm putting brackets or braces instead of parentheses, and I'm going off in opposite directions. To write it as an inequality, I would say, well, this goes to -infinity over here all the way up to, reading it from left to right. So all of this in yellow is this guy, and all of this in blue over here for this solution would be from 3 to infinity. If it's an equal sign, you don't draw any arrows, you just drop 2 points down. If they're not equal, I have open dots, which we know as parentheses. So to graph something like this, I would say 3x plus 7 is less than 8. That's a less and symbol here. So I already know that the graph is going to come together, but I'll finish writing this. And 3x plus 7 is greater than -8. So I'll subtract 7 from both sides. 3x is less than 1. X is less than 1/3. Hard to graph, but I'll get close on my number line. Subtracting off 7 gives me 15. Dividing by 3 gives me -5. So this is an AND statement, so I know that the graphs should come together. Let's make sure that I've done this correctly. I need all the values of x that are greater than, but it can't be equal to -5, and I'm just going to guess where 1/3 is, somewhere in here, and it's a between statement. So I will say I need all the values in between. This is your AND statement. I could rewrite this probably using the lower number goes on the left and use less than symbols. So I could rewrite it really like I need all the values of x that are between -5 and 1/3. Interval notation is a little bit easier. Can't include the -5, can't include the 1/3. Just make sure the lower number goes on the left. I'm not a big fan of this notation. I would prefer putting the lower number on the left and use less than signs. Another example here, 8 minus 4x is less than or equal to 5. This is a less and symbol again, so and 8 minus 4x is greater than or equal to -5. So solving by subtracting off 8 from both sides, -4x is less than or equal to -3. When you divide by a negative in this case, you are going to flip the inequality sign. It's not because the 3 is negative, it's because I divide by a negative. So x is greater than or equal to 3/4. Over here, if I subtract off 8, -4x is greater than or equal to, so I've initially flipped the sign once already because of the absolute value. It's interesting. I'm going to flip this inequality sign for the second time on this side because I'm dividing by -4. So that will flip the sign back and give me a 13/4. Since this is an AND statement, I can write the lower number, put the lower number on the left, and use less than symbols. So again, 3/4 is lower than 13/4. And I can include the 3/4. I'll put a bracket there, and I can include the 13/4. 3/4 is a little bit less than 1. So there's a 3/4. And 13/4 is a little bit more than 3. And it's a between statement. So the graph looks like, here's the solution, and there's the graph. One last example here. I will say 4x plus 2 is greater than or equal to 6. Great or means I'm going to use the or statement. 4x plus 2 is less than or equal to negative 6. Subtracting off 2. 4x is greater than or equal to 4. Dividing by 4 gives me a 1. Or subtracting off 2 will give me negative 8. Dividing by 4 will give me a negative 2. And I cannot write this putting the lower number on the left and use less than signs. I have to keep this as a separate statement. And likewise, usually I have for or statements 2 parentheses because I want everything over to the left, including negative 2. So this would be stated as from negative infinity up to negative 2. And then this red one would say I want everything greater than or equal to 1. And I could say, well, that goes from 1 to infinity. Remember, keep the lower number on the left and keep moving over to the right to organize those. So good, the author agrees. I hope this video was helpful. If you have any questions, feel free to email.